we are going to begin with something remarkable, something really cool. Between your eyes and the screen you are looking at, there are not hundreds or thousands or millions or even billions of air molecules. There are literally trillions of air molecules between your eyes and that screen. Isn't that absolutely amazing? The atmosphere is really a churning ocean of molecules. When you think about the ocean and what it looks like and what it does, you know there's currents there and there's waves there and there's eddies swirling around and warm waters rising and cold waters subsiding. There's all of this movement happening within the ocean. The atmosphere is actually a very fluid body, very similar to water in many ways. And it is churning in the same way that the ocean churns. There are currents, there's rising bubbles and subsiding bubbles, there's swirling eddies, there's all of this movement that's constantly happening within the atmosphere. It's such a cool part of our Earth system, but it's something I think that mostly gets overlooked by people. The atmosphere, of course, is indispensable to life. Can we live without a planet? Maybe. People are in spaceships. They're not on a planet. But you know what they're not going to be able to live without? Air. It's impossible to live without air. You can't have the Earth system we have without the atmosphere. It's that critical of a component of the Earth system. And in fact, the atmosphere is so important that if you only went up 5 miles, maybe a little higher than that, you would begin to suffocate because the atmosphere thins out so rapidly. Almost every bit of life is found from the surface of the planet to just about 5 miles above us. That's it. It's all confined to a very small place. If you think about the Earth being a beach ball, just a normal sized blown up beach ball, maybe 18 inches across, the atmosphere, if the Earth was the size of a beach ball, would be the thickness of a piece of paper, maybe even a little less than that. But it is that atmospheric ocean that allows you right now to even hear my voice. Because on the moon, where there is no atmosphere, there's also no sound. You need vibrations going through the atmosphere to hit the cilia in your ears to be able to make your brain discern sound. That doesn't happen without an atmosphere. The Earth system is an interrelated system. Each part works with the other parts, and you cannot extract one part and expect the others to function the way they function as we see them functioning right now on this planet. You can't even alter them very much without radically changing the other components. And there are 4 components to the Earth system: the atmosphere, the lithosphere, the hydrosphere, and the biosphere, which are, of course, air, land, water, and life. Atmos means air in Greek, sphere is a ball, like the Earth is. Lith is one of the words for rock. Hydro means water, and bios means life. Those are the 4 components of the Earth system. Those 4 components always operate together. Our focus, of course, in this class is the atmosphere, which is the blanket of air surrounding the Earth that consists mainly of a mixture of gases. If you think about what a blanket does, what happens to you when you lay on your bed and you put a blanket over the top of you? The blanket keeps you warm, right? Well, it's not the blanket. It's that the blanket is keeping the heat energy from your body from escaping further up into the air. And then that heat energy surrounds your body and you're able to stay warm. The atmosphere works in a very similar way. And you can see this photograph here. You can see the atmosphere there. It's incredible. Well, the atmosphere has not always been the same. The atmosphere has gone through an evolution. that's brought us to the point where we are right now. The early atmosphere, in all likelihood, was made up of hydrogen, helium, methane, and ammonia, not really a livable atmosphere. Then there were changes from tectonic activity, volcanic activity. Gaseous water was infused into the atmosphere, carbon dioxide, some nitrogen. Outgassing, which is the expulsion of gases from the Earth's interior, largely because of tectonic activity, moving around in the tectonic plates, and then gases being expelled up in explosive eruptions, went in and changed the atmosphere. It increased water vapor, which allowed for the creation of clouds and precipitation. Imagine the atmosphere with no clouds or precipitation. That would be Mars. Carbon dioxide was slowly stripped from the atmosphere by precipitation, and it was sequestered in the oceans and in limestone. Additionally, plants sucked carbon dioxide out of the atmosphere and then were also sequestered under the ground and became our fossil fuels. Decreased carbon dioxide, though, increased the concentration of nitrogen. And solar radiation splits the water molecule, which increases oxygen. And in addition to that, as plants evolved, plants expelled oxygen, and we have created our modern atmosphere. It's kind of complicated. The atmosphere is made up of these gases: 78% nitrogen, 21% oxygen, 0.9% argon. Carbon dioxide is about 0.04%. This has been increasing over the last 250 or so years. And then other, at least at this point, accounts for 0.06%. Let's see where the Earth is. If you look, this is our Milky Way galaxy on the left and the right. Of course, these are diagrams of them. We haven't actually been out far enough to take a picture like this yet. But if you look, the Milky Way is a swirling galaxy. So you can see that on the left-hand side. On the right-hand side, you can see where we are. We're way out on one of those arms that swirls around the center of the Milky Way galaxy. Sometimes, if it's very clear and you look up, you can see the Milky Way. It looks very much like that I just circled for you. It's a bright band of stars cutting diagonally across the sky. When you're looking at that, remember, we are way out on the far edge of the Milky Way galaxy. You are looking into the center of the Milky Way galaxy, and keep this in mind. There are billions of stars, and in all likelihood, billions of planets in the Milky Way galaxy. And there are billions of galaxies, all with billions of stars. At the same time, when you look up at night, on a clear night, or for that matter, a night that's not very clear, everything you are looking at is within the Milky Way galaxy. Only if you knew where to look on the clearest of nights would you be able to see a tiny fuzzy dot that is the closest galaxy to us. Other than that, everything you're looking at is within our galaxy. And where are we within that galaxy? We're kind of in the sweet spot, the Goldilocks zone, so-called, which is in our solar system right there. There's Earth. We're about 93 million miles out now from the sun. Now, the thing about that is that 93 million miles in a lot of ways is actually too far away. The thing that makes this planet livable is the atmosphere. That's right, it's the atmosphere. Now, there are a number of planets that have atmospheres. Mars has an atmosphere that's very thin. Venus has a very dense atmosphere. Jupiter, Saturn, Uranus, Neptune all have atmospheres, but none of those are livable. Ours is the only one that's livable. So even when they find a planet that's going around another sun in some other solar system, and it's about the same size planet as us, and it's about the same distance away, it better be composed of the same atmospheric gases and have gone through a very similar evolutionary process to us, or it's highly unlikely there will be life on it.